this warm-up's intended to drive some instruction today, okay? Some people certainly will say May because between 6 and 10, it went down how much?
9.
And between 4 and 6, it went down how much?
8.
But between 4 and 6, it went down 8 over 2 hours, which is 4 degrees per hour. And from 6 to 10, it went down 9 over 4 hours, which is 2 1/4 degrees per hour. So, Tyler is actually correct. The question, again, let's watch. It doesn't say that. It says which one dropped faster. Okay? That doesn't mean which one dropped more. Faster would be 4 degrees per hour than 2 1/4 degrees per hour.
But
Is it faster if someone runs 4 miles per hour or 2 miles per hour?
2. Wait.
4. Yeah, so again, if you picked May, this is intentional. This is intentional because if you have that misconception or that thing where you didn't look at the interval of time, it's supposed to spark your brain to say, oh, I need to look at more than just how much it changed by. Also, if you watch Dude Perfect, you know you never pick against Ty.
Oh, yes.
You never pick against Ty.
Yeah.
He always wins. So what I would like you to do is we're going to take a look here at hours since noon and temperature. We have a table and a graph, so you have different tools you can choose to utilize in order to answer these questions. You're going to do this in your math notebook. Question 1, you want the average rate of change between noon and 1, noon and 4, and noon and midnight. And then you're going to reference May and Ty's disagreement and use the average rate of change to show which time period 4 to 6 or 6 to 10 experience a faster temperature drop. This is all in your math notebook with your partner. You can't use a calculator for this. So I'm looking for a little help from noon to 1. This is if you're not inclined to raise your hand, this is the one to help on. Okay. Yeah, Will, how much did it change by on that interval between noon and 1?
On average?
Yeah.
1 degree.
Yeah. Right here. It went up 1 degree over 1 hour. So I'm going to write that as 1 degree per hour. That's my average rate of change from noon to 1. So it's getting hotter. All right. Next interval, we're going to look at noon to 4. Micah, help me out with that. How much did that change by?
1.75.
Yeah, so I'm gonna not overkill. I'm going to really communicate how we're getting things. What I'm gonna do is I'm gonna do 25 minus 18. And what is that telling me?
25 minus 8.
Noon. What is that telling me?
The total change.
The change in my temperature, and I'm going to divide that by what, Micah?
The amount of time, so 4.
4 hours minus 0. This equation, change in y over change in x, looks the same as what equation? It's change in y over change in x. Not the same. Slope. Rise over run. Slope. The average rate of change is like the slope between these 2 points. We're just not going to call it slope because this is not a line. It's kind of a line between here and here, right? We're finding the slope of that line. So what this is going to give us is 7 divided by 4, which is 1.75 degrees per hour. So is the average rate of change greater between noon and 1 or noon and 4? Yeah, and that's probably because the hottest part of the day is usually around 3 p.m. So maybe that plays in, maybe. Just think. Next, we have an interval between noon and midnight. Who can help me figure out how to find what that average rate of change is? Hadley.
It goes down 11 possibly.
Yeah, so 7 minus 18, the change in temperature, second point minus first point. And then how many hours? 12. So I've got negative 11 twelfths, right? Which as a decimal is negative 0.917, let's say, degrees per hour. So that is going from here to there. So what's interesting is all of this data that I have is true. Correct? Would you agree? Does C help explain the situation well if I had just C? Okay. Does it just trend down for the day? No, it gets warmer and then what happens? Then it gets colder. So This is where a lot of times we want or need more context or look at different intervals. Because if you just said, hey, chilly day today, on average, the temperature decreased almost a degree per hour. But it increased for a period, but that gets lost if I just look at the average rate of change, right? So we might, like if we were going to do this, we might want to like write different intervals. If I was going to explain the day, I would say something like the average rate of change in this part, and then average rate of change in that part, maybe. Okay? It's all about communication, and just always know, sometimes you need more information for a situation. Data can be misleading. You guys know that? Yeah. It can be misleading. So thinking back to May and Ty's disagreement, which time period, 4 to 6 or 6 to 10, had faster temperature drop? Raise your hand if you think 4 to 6. Raise your hand if you say 6 to 10. Okay, there's only one way to find out. 4 to 6. The temperature went down by how much?
8. A lot.
I got 7. 8, sorry. It went down 8 over 2 hours, which again was 4 degrees per hour. We already kind of saw this. And 6 to 10 was negative 9 degrees over 6. Wait. I messed up. So 4 to 10, okay, was 25 minus 8. No, sorry, 6 to 10, not 4 to 10. 17 minus 8. So that went down, remember, 11 over 4 hours. So 11 divided by 4. So again, Ty, remember, Ty was right. Yes, so it's a faster temperature drop.
Oh no, I know.
Yep, they're both negative. Did I not? Oh, I didn't write negative there. They are. There you go. So we need to look at the interval. This is real data, although this data has probably changed since COVID. Actually, I know it's changed since COVID. But this is the populations of California and Texas. Your job is to estimate the average rate of change in those populations between 1970 and 2010. And then just say what that means. And then for 2, you're going to look between the interval of 1900 and 2000 and see which ones grew more quickly. So you and your partner. Is this, when we go over this, will your answer for sure be exactly the same as mine? No. What was nice on that last one that we had to reference for data? Yeah, we had a table. You're going to pull from a graph. Just do your best. Right? That's why it says estimate. So get after it with your partner. I'm going to be asking for a little calculator help because I'm wandering around right now. So average rate of change between 1970 and 2000. For me, I'm going to write like this just to give myself a frame of reference. And I kind of just going to put some dots on there. That's going to help me out.
2010.
Oh, my bad. See, that's why. You know that I did it wrong because I communicated what I was doing. Okay. So let's work on Cali first. Okay? So I'm going to go second point minus first point for population. And I think I chose something about like 38 million minus 20 million. And I'm dividing that by 2010 minus 1970. Okay? And so 18 divided by 40. Someone do that for me. Well, let me try it. Hey, don't tell me yet. 18 divided by 40 is 9/20ths, which is 45 hundredths. Is it 0.45?
That's correct.
Million per year. Okay, so I'm going to circle that as my reference. So California's population in that interval, and kind of, guys, what I did, I kind of found the slope of that line I just drew on there, right?
Yeah.
But we're going to call it average rate of change because it's an interval in a greater scheme of things. Next, let's look at Texas. I used to live in Texas. Okay? And all my exes live in Texas.
Oh.
Now that's a song by Dolly Parton.
How many
Okay,
X's do you have?
none. But let's do Texas. Shh. It's just a song. So again, what I'm going to kind of do is I'm going to find the slope of that, if that were a straight line. I could draw it straighter, I think. The slope of this line kind of is what I'm doing, okay? So Texas ended up being about 25 million. And it started at about 11 million. And that's still over that 2010 minus 1970 interval. So who can please Hit me with 14 divided by 4. No, I got this. 7/20 is 35 hundredths. So their growth is about 0.35 million per year. Did anybody write that in thousands, at like 350,000 or something instead? Yeah, that's cool. Same diff. Yeah. So Spencer said, it used the word estimate and we're pulling from a graph. So you got a little different number, but same idea, right? Same interval. So what does each rate of change mean? I'm just going to write the number of people who move there yearly on average from 1970 to 2010. That's what it means. It literally means that. So it means the number of people who move there yearly on average in that interval. Now, do you think that's the same on average if we did like all time or a different interval, or is it maybe different? It's probably different. So looking at problem number 2, Will, what do you notice about our time interval on 2? Is it the same? No, so we're looking 1900. We got 1900 right there. So what I like to point out is I'm not even going to math this thing that much. Which one started higher in 1900? Texas. Which one ended higher? So which one has to have a greater rate of change? Cali. I'm just going to write started lower. Ended higher. So we could calculate the rate of change, but we don't need to. Are you guys seeing that? On this one, you don't need to if we're just saying which one's faster. So if you did calculate it, it's cool. You would be looking at like these lines if you calculated it, right? And you could see, nope, I did that wrong.
No.
That's Cali.
Oh.
That's Texas. So the one that's steeper would have the greater rate of change. Just because this one asked which one's faster, I just chose the one that I can see is faster because it's steeper. All right? And that probably has something to do with Hollywood. I'm guessing. Hollywood got people, and maybe people could get there easier from flying. Let's see. What year was Hollywood established?
1924.
1887, but that's when they like made the neighborhood or something. But it did in like 1910s is when they started making some legit movies. So the boom probably happened after, probably Hollywood. I'm just guessing the cause. All right, lesson summary, hit it up at your assigned seat. Got this lesson summary quick. So between 9 and 2, how was it rising? So I'm going to be looking at this interval from here to here. So it goes from 35 up to what? 35 to 45. Oops. And my interval from 9 to 2, which is, this one's a little tricky because it's time, right? This almost doesn't work very well, but it is 5 hours. So it went up 10 degrees over 5 hours. That's 2 degrees per hour. That's the slope of this fake line. All right, yeah, Tess. No, temperature over time. Yeah. Y over X. Change in Y, delta Y, over change in X. It's delta X. So how quickly was it falling between 2 and 8? So my reference points are here and here. So from 2 and 8, it ended at 30, started at 45. And from 2 to 8 is 4 hours. 15 divided by 4 is negative 3.75 degrees per hour. Or if you actually wrote the words, it fell by 3.75 degrees per hour, that would also indicate the negative part of it.